Alright, so this is Chapter 11, Section 5, Volume of Pyramids and Cones. It's only two equations really that you need to know for this. First one is the volume of a pyramid. So here's a pyramid. It has a height. The height is from the vertex of the pyramid, the very top of the point of the pyramid, all the way down to the center of the base of the pyramid. It forms a perpendicular intersection with the center of the base. And the equation is that volume is equal to 1/3 the area of the base times the height of the pyramid. When we talk about volume, our units are always cubed. So feet cubed, inches cubed, centimeters cubed. They're always cubed. When we talk about area, the units are always squared. When we talk about perimeter or circumference, the units are always to the first power. So in this particular case, we're dealing with volume, so our units are going to be cubed. So the example that they have here, they say there's a sports arena shaped like a pyramid with a base of 300,000 feet and the height of 321 feet. What is the approximate area volume of the arena? So volume equals 1/3 the area of the base times the height. In this case, our base is 300,000 feet and our height is 321 feet. We just substitute 300,000 for base, 321 for height, so it's going to be 1/3 300,000 times 321. And that will give me a big number. $32,100,000 feet cubed. 32,100,000 feet cubed. So problem number 2, it's pretty much the same thing. The only difference is that they don't give you the height, they give you the slant height. So we have a pyramid. It's a they tell me it's a square pyramid, and that's important. If it's a square pyramid, I know I'm dealing with a regular polygon, and that's very helpful. It has a slant height of 25, and it has this distance here and this distance here, and we're trying to find the vertical distance, which is the height, which is perpendicular to the base. They draw a smaller subsection of the triangle down here. This is the triangle associated with the pyramid. This is the height. This is the slant height, which is 25. and then they want to find out what the height is. We know that the whole entire base is 40. Since we're dealing with a square, this height comes straight down in the middle, and it hits it at halfway point of 40. So this is going to be 20. And because that's the apothem of a regular quadrilateral. So this is 20. This is a right triangle since the height forms a perpendicular intersection with the base. So we can use the Pythagorean theorem to find out the height. The 25 is our hypotenuse, and then the 20 is our leg. And so we're going to find the other leg, which is the height. Since it's a squared plus b squared equals c squared, we're trying to find what the height is. We'll call that a. It's going to be c squared minus b squared equals a squared. So then I would square root all of that. C squared minus b squared equals a. So that is our Pythagorean theorem to find the height. So instead of calling it a, we'll call it h. Instead of calling it c squared, we'll call it 25 squared. The book does it for us right here. So this would be 625 minus 400, which gives us our h, which is 15. So we have our height. Now that we have our height, we can plug in using our equation, volume equals 1/3 base times height. Since we have the height of 15, the base area of the base is going to be 20 times 20, since 40 times 40, since the length of one side is 40, and that would give us 1/3 40 squared times 15, and the book says that that's going to be 8,000 feet cubed. So there's going to be two ways that you find there's going to be one way that you find the height, and that's using the Pythagorean theorem. If they give you the slant height of the period only. If it's a square pyramid, the apothem is always going to be halfway through. So you always just divide that side of the base by 2 to get that second side, and then you can use the Pythagorean theorem to find the height. So the example they want us to do is here they say the volume of a square, and that's important that it says square, pyramid with edges 24 and a slant height of 13 meters. So if I was to try and draw this pyramid, it says that the edges are 24. The base edges are 24. So the base edges would be 24, and the slant height would be 13. So if I was to pull that triangle out, it would be height 13, and then half of 24 is 12. and then I would use the Pythagorean theorem. So this would be 13 squared minus 12 squared equals h square root that all. It's going to be 169 minus 144. Which gives me square root of 25, which is the height, which gives me my 5. So the height is 5. And then to find the base, it's just going to be 24 squared which is 576. So volume is equal to 1/3 the area of the base times the height, which is 1/3 576 times 5. Which gives me 960 feet, no, sorry, meters cubed. 960 meters cubed. So again, you use the Pythagorean theorem to find the height, given the slant height, and knowing that half of the base is going to be the apothem of a square. After you find the height, you square the side of the base to get the area of the base, and you multiply those, divide them by 3, and you get your volume. And this is for a pyramid. The other shape that we're dealing with is that of a cone, and the equation is exactly the same. Volume equals the area of the base times the height. The only difference is that instead of it being a square base or a triangular base or whatever base it is, for a cone, the base is the circle. So since it's 1/3 base times the height, we know that the equation for the base of a circle is pi r squared. So you would use 1/3 pi r squared times the height. And most of the time your answers are going to be in terms of pi. So here for 3a, they say the height and radius of a child TP are half of those of the TP in problem 3. So if the height was 12, or the height is 12, then it would be 6. If the radius was 7, then it would be 3.5. So we have radius equals 3.5, height equals 6. The volume of a cone is 1/3 pi r squared times the height. So that would be 1/3 3.5 squared times 6 pi. And I get 24.5 pi. It's going to be feet cubed. I'm not going to round it to the nearest whole foot or 100 foot. Most answers when involving cones and cylinders are going to be, and spheres, are going to be in terms of pi. So the radius is squared, 3.5 squared, which is 12.25. I multiply it times the height, which is 6. Then I divide it by 3. and I got 24.5 pi feet cubed. Alright, in this example over here, we have an oblique cube cone. The thing about the oblique cone is that it's not the vertex is not perpendicular to the base, or I should say, it does not hit the perpendicular intersection. Doesn't occur at the center of the circle of the base. It's off center. So the example that they give us down here is that we have an oblique cone. The height is 12. The radius is 6. Again, volume equals the area of the base times the height. In this case, it's going to be pi r squared times the height. So our volume would be 12 squared times 6. Oops, nope. 12 is the height. 6 squared times 12 times pi, which is 36 times 6. Which equals 432 pi. In this case, it's going to be in meters cubed. So the radius is 6, we squared that and got 36, the height is 12, so 36 times 12 would give us 432, and it would be 432 pi. And we have a pyramid here for do you know number 1. They give me a height of 8, and I have the side of 6. We could say that the area of the base is going to be 6 times 6, which is 36. And I'll rewrite that. 6 squared, which is 36. Volume of a pyramid, 1/3 area of the base times the height. So it's going to be 1/3 times 36 times 8. And I get 96. That's going to be 96 inches cubed. And then for this last one, we have for a cone, radius of 1, height of 3. For a cone, volume equals 1/3 pi r squared times the h. So volume equals 1/3 1 times 3. We get pi. How neat. So centimeters cubed. Okay. So that is section 11.5, volume of pyramids and cones. Hope you guys have a great day.